Venus always looked simple to me. Just a ball of rock floating in space, orbiting the sun, almost the same size as Earth. Nothing special. But once I actually started digging into how a planet like Venus works, everything changed. I didn't expect to find a world this broken, this hostile, and this bizarre. I'm talking about a planet where the sky is heavy enough to crush metal like a paper, where the days last longer than the years, a place where the laws of nature seem to have broken. The deeper I went, the more shocked I became at how much I never knew. From a distance, Venus looks like Earth's perfect mirror. It orbits just about 26 million miles closer to the sun than we do. In fact, because of its thick white clouds, for centuries we assumed Venus was just a warmer, mistier version of Earth. A tropical jungle hiding under a permanent overcast sky. A twin world waiting to be explored. But that fantasy ended when humanity finally sent probes to penetrate those clouds and map the surface. Venus is buried under a suffocating blanket of gas, almost 70 kilometers deep. And at the bottom of that blanket, the surface isn't tropical. It is 900 degrees Fahrenheit, hot enough to melt lead, hot enough that if you stood on the surface, you wouldn't just burn, you would be incinerated instantly. But heat alone doesn't define Venus's hostility. It's the atmosphere. The atmospheric pressure on Venus is 92 times stronger than Earth's. Standing on the surface would feel like being 3,000 feet underwater. It presses against every inch of your body with over 1,300 pounds per square inch. To put that in perspective, a standard nuclear submarine, a machine built to withstand the crushing weight of the deep ocean, would be instantly flattened on Venus's surface. Not gradually compressed, instantly destroyed. This heavy atmosphere blocks almost all wind erosion. The ground isn't smooth or sandy like Mars. It is a jagged expanse of razor-sharp, dark gray basalt rock. This barren crust covers huge rolling plains that stretch across 80% of the planet. But these plains aren't just ancient dead rock. They're volcanic. Over 80,000 volcanoes have been mapped on Venus's surface, more than any other planet in the solar system. And here's what makes it worse. The planet is still alive, still burning, still locked in an endless volcanic cycle. And then there's the composition. Venus's atmosphere isn't made of nitrogen and oxygen like Earth's. It's mostly carbon dioxide, with clouds of sulfuric acid droplets. The same corrosive substance that dissolves flesh. If you exposed human skin to these clouds, the acid would strip it away. And inside those clouds, a terrifying weather cycle is happening. It rains sulfuric acid, but this rain never hits the ground. The surface is so incredibly hot that the acid raindrops boil and vaporize while they are still 15 miles in the air, turning back into gas before they can ever touch the rock. But the clouds aren't just poisonous, they are electrically charged. Venus experiences lightning, but not like the storms we know on Earth. Here the bolts don't strike from water clouds. They erupt within the sulfuric haze. We don't fully understand what triggers it. It could be volcanic ash charging the sky, or an unknown chemical reaction in the acid itself. So Venus looks like Earth, sits near Earth, but it's actually a nightmare world. The question is, how did Venus become so different? To understand Venus, we need to go back billions of years, to the very birth of our solar system. Early Venus likely wasn't so different from early Earth. Both were young, volcanically active, and both had carbon dioxide in their atmospheres. But Earth has oceans, water, and life. These systems created a feedback loop that stabilized the planet, a process that took millions of years. Venus didn't have that luck. Venus is closer to the sun and it receives more solar radiation than Earth. This meant the oceans, if they ever existed, would have evaporated faster. As water vapors rose into the upper atmosphere, ultraviolet radiation from the sun broke those water molecules apart. Hydrogen escaped into space. Oxygen reacted with surface minerals and combined with carbon to form more CO2. When Venus's thousands of volcanoes erupted, belching out massive amounts of carbon dioxide and sulfur, those gases had nowhere to go. They simply piled up. The temperature climbed and climbed until it reached the inferno we see today. But here's where Venus gets even weirder. Venus rotates backward compared to most planets. We call this retrograde rotation. Scientists believe that billions of years ago, a massive object, perhaps a protoplanet the size of Earth, slammed into Venus with such force that it literally knocked the planet upside down, reversing its spin forever. And that impact might explain why it spins so slowly. Venus rotates so slowly that one day on Venus, one complete rotation, takes 243 Earth days. But a year on Venus, one orbit around the Sun, takes only 225 Earth days. That means a day on Venus is longer than a year on Venus. But the rotation anomaly isn't the only impossible thing about Venus. While the planet below spins in slow motion at around 7 kilometers per hour, the atmosphere above is racing at a hurricane speed of over 360 kilometers per hour. It's far larger than anything Earth experiences, and it never stops. It is a perpetual planet-wide storm that has been raging for billions of years. It's as if the atmosphere and planet exist in different worlds, only loosely connected by gravity. So, what does the ruin of Venus truly teach us? It teaches us that in the vast, cold emptiness of space, location is survival. Astronomers call it the Goldilocks zone, a fragile, narrow ribbon of space around a star where conditions are not too hot, not too cold, but just right for water to flow and life to breathe. And this is where we realize just how fortunate we are. Earth hangs perfectly in the center of this cosmic oasis. It is proof of how razor-thin the margin for life really is. The deeper we study Venus, the more we realize how much we never knew about our own planet's future.